AC power plugs and sockets are devices that allow electrically operated equipment to be connected to the primary or alternating current power supply in a building. Electrical plugs and sockets differ in voltage and current rating, shape, size and type of connectors. The types used in each country are set by national standards, some of which are listed in the IEC Technical Report ER 60083. Plugs and socket outlets for domestic and similar general use standardized in member countries of IEC. Plugs and sockets for portable appliances started becoming available in the 1880s to replace connections to light sockets with easier-to-use wall-mounted outlets. A proliferation of types developed to address the issues of convenience and protection from electric shock. Today there are approximately 20 types in common use around the world, and many obsolete socket types are still found in older buildings. Coordination of technical standards has allowed some types of plugs to be used over wide regions to facilitate trade in electrical appliances, and for the convenience of travelers and consumers of imported electrical goods. Some multi-standard sockets allow use of several different types of plugs. Improvised or unapproved adapters between incompatible sockets and plugs may not provide the full safety and performance of an approved socket and plug combination. Concepts and terminology. Generally, the plug is the movable connector attached to an electrically operated device's mains cable, and the socket is fixed on equipment or a building structure and connected to an energized electrical circuit. The plug has protruding prongs, blades, or pins that fit into matching slots or holes in the sockets. Sockets are designed to prevent exposure of bare energized contacts. Sockets may also have protruding exposed contacts, but these are used exclusively for earthing, to reduce the risk of users accidentally touching energized conductors and thereby experiencing electric shock. Plug-in socket systems often incorporate safety features in addition to the recessed slots or holes of the energized socket. These may include plugs with insulated sleeves, recessed sockets, sockets with blocking shutters, and sockets designed to accept only compatible plugs inserted in the correct orientation. The term plug is in general and technical use in all forms of English, common alternatives being power plug, electric plug, and plug top. The normal technical term for an AC power socket is socket outlet, but in non-technical common use a number of other terms are used. In British English the general term is socket, but there are numerous common alternatives, including power point, plug socket, wall socket, and wall plug. In American English receptacle and outlet are common, sometimes with qualifiers such as wall outlet, electrical outlet and electrical receptacle. All of these sometimes to be found in the same document. A socket may be surrounded by a decorative or protective cover called the wall plate, face plate, outlet cover, socket cover, or wall cover. In some designs this is an integral piece with the socket itself, bought and installed as a single unit. Electrical sockets for single-phase domestic, commercial and light industrial purposes generally provide either 2 or 3 electrical connections to the supply conductors. 2-pin sockets normally provide neutral and line connections, both of which carry current and are defined as live parts. Neutral is usually very near to earth potential, usually being earthed either at the distribution board or at the substation. Line carries the full supply voltage relative to the neutral. 3-pin sockets provide, in addition, a protective earth connection for exposed metal parts of an appliance. If internal insulation should fail, a short circuit to the earthed exposed metal parts will hold them at a low potential, and should operate fuses or circuit breakers to isolate the faulty appliance from the supply. Depending on the supply system, some sockets may have 2 line connections, each at significant voltage to earth and without a neutral pin. For example, a split-phase system may have 240 V between line connections, each at 120 V with respect to earth ground, but a single-phase receptacle connected to a three-phase system may have, for example, 208 V between contacts and only 120 V between each contact and earth-ground. History. Early history. When electricity was first introduced into houses, it was primarily used for lighting. At that time, many electricity companies operated a split tariff system where the cost of electricity for lighting was lower than that for other purposes. This led to portable appliances being connected to light bulb sockets using lamp holder plugs. As electricity became a common method of operating labor-saving appliances, a safe means of connection to the electric system other than using a light socket was needed. According to British author John Mellanby, the first plug and socket in England was introduced by T.T. Smith in 1883, and there were two-pin designs by 1885, one of which appears in the General Electric Company Limited catalogue of 1889. Gustav Binswanger, a German immigrant who founded the General Electric Company Limited, obtained a patent in 1895 for a plug and socket using a concentric contact system. Several early American electrical plug-and-socket arrangements were invented by Harvey Hubbell. On February 26, 1903, he filed two patent applications featuring two-pin plugs and adapters for using his plugs with existing designs of lamp sockets and wall receptacles. Hubbell's first plug design had two round pins which differed from those already in use in Europe in that the tips of the pins had annular detents, similar to those of present-day jack plugs, to positively retain a plug in its socket. In one patent, US 774, 250, a plug was used with a socket which screwed into a lamp holder. In the other patent, US 776, 326, the same type of plug was used with various three-way adapters that could be connected to lamp holders or a receptacle of any ordinary type. Figures 2 and 4 of this patent show an adapter plugged into what appears to be a Chapman receptacle. Hubbell evidently soon found the round pin design unsatisfactory, as a subsequent patent, US 774, 251, filed on May 27, 1904, shows lamp holder adapters similar to those of his first patent for use with plugs having coplanar flat pins. Hubbell's catalogue of 1906 includes various three-way adapters similar to those shown in the US 776, 326 patent, but modified for use with the coplanar flat-pin plugs. The Chapman receptacle must have been in general use at the time, as it was the only type of non-lamp holder receptacle for which adapters were supplied. The 1906 catalogue says of the Chapman adapter, "The device avoids fastening the cords together as is necessary with the ordinary Chapman plug when used for more than one purpose." This suggests that Hubbell's original invention was prompted by his observation of the problem that arose with the use of this sort of receptacle and plug. Hubbell subsequently rotated the pins by 90 degrees to arrive at the configuration still widely used today. Other manufacturers adopted the Hubbell pattern, and by 1915 they were widespread. Gradually, wall sockets were developed to supplement those that screwed into lamp holders. The Earthed Consumer plug has several claimants to its invention. A 1911 book dealing with the electrical products of A. P. Lundberger and Sons of London describes the Trippin earthed plug, available in 2.5 amp and 5 amp models. The pin configuration of the Trippin appears virtually identical to modern BS 546 plugs. In her 1914 book Electric Cooking, Heating, Cleaning, etc., Maud Lucas Lancaster mentions an earthed iron-clad plug and socket by the English firm of Rerol & Co. The earliest American patent application for an earthed plug appears to be the 11th of January 1915 by George P. Knapp, on behalf of the Harvey Hubbell Company. This patent covers the use of an earthing pin which extends further than the other two contacts to ensure that it is engaged first. The configuration of the socket was not operable with existing two-contact and earthed plugs. Other earthed sockets that are widely used in the U.S. today are operable with unearthed plugs. The German Schuco system plug is believed to date from 1925 and is attributed to Albert Butner. The current American version of the earthed plug, with two parallel blades and a round earthing pin, was invented by Philip F. Labra while he was attending the Milwaukee School of Engineering. It is said that his landlady had a cat which would knock over her fan when it came in the window. When she plugged the fan back in, she would get an electric shock. Labra deduced that if the fan was earthed, the electricity would go to earth through the plug rather than through the person holding it. He was issued a U.S. patent for an earthed socket and plug in 1928. As the need for safer installations became apparent, earth-3 contact systems were made mandatory in most industrial countries. Proliferation during the first 50 years of commercial use of electric power, standards developed rapidly based on growing experience. Technical, safety, and economic factors influenced the development of all wiring devices, and numerous varieties were invented. Gradually, the desire for trade eliminated some standards that had been used in only a few countries. Former colonies may retain the standards of the colonizing country. Sometimes offshore industrial plants or overseas military bases use the wiring practices of their controlling country instead of the surrounding region. Some countries have multiple voltages, frequencies and plug designs in use, which can create inconvenience and safety hazards. Hotels and airports may maintain sockets of foreign standards for the convenience of travelers. Consolidation. De facto standards became formalized as official national and international standards. Old installations with obsolete sockets exist. The International Electrotechnical Commission in 1934 established Technical Committee TC-23 for electrical fittings. Only 2 meetings were held before the outbreak of the Second World War. In Europe, since 1951, the International Commission on the Rules for the Approval of Electrical Equipment has published a standard describing the plugs and sockets used. In 1953, the CE published Technical Report 83, which was a listing of plugs and sockets then in use. In North America, the National Electrical Manufacturers Association publishes standards for plugs and sockets. The international standard IEC 60884-1 defines the general requirements for plugs and sockets intended for household and similar purposes. IEC 60884-1 does not define specific plug and socket types, which are the subject of national standards in each country. IEC 60884-1 para 9.2 does stipulate that it shall not be possible, within a given system, to engage a plug with a socket outlet having a higher voltage rating or a lower current rating. IEC 60884-1 para 6.1 defines the preferred voltage ratings for single-phase plugs and sockets as 130 V or 250 V. The foreword of IEC 60884-1 states, in order to promote international uniformity, IEC national committees undertake to apply IEC publications transparently to the maximum extent possible in their national and regional publications. Any divergence between any IEC publication and the corresponding national or regional publication shall be clearly indicated in the latter. Consolidation of standards eases international trade and travel. For example, the C7/7 plug has been adopted in several European countries and is compatible with both C7/3 and C7/5 sockets, while the unearthed and unpolarized Europlug is compatible with even more European and other socket types. IEC 60906-1 has been proposed as a common standard for all 230 V plugs and sockets worldwide, but has been adopted only in South Africa so far, with a modified version used in Brazil. IEC 60906-2 recognizes the wide use of the NEMA 5-15 parallel blade plug and socket and recommends it for all 120 V applications. Application issues. Design features of plugs and sockets have gradually developed to reduce the risk of electric shock and fire. Safety measures may include pin and slot dimensions and layout that permit only proper insertion of plug into socket, and earth pins longer than power pins so the device becomes earthed before power is connected. Electrical insulation of the pin shanks was added to some designs to reduce live contact exposure when a plug is partially inserted in a socket. Shutters that open only for the correct plug prevent foreign objects from contacting live slots. Some types include fuses and switches. Earthing: a third contact for a connection to earth is intended to protect against insulation failure of the connected device. When earth distribution systems became common, earlier unearthed socket types were either replaced with new standards, or revised to include an earthing pin. Different types of plugs are used for different IEC appliance classes. The assigned class depends on whether or not the device is earthed, and the degree of insulation it incorporates. Class 1, for example, refers to earthed equipment which requires a third contact in the plug and socket, while Class 2 refers to unearthed equipment protected by double insulation. Polarization: where the building wiring system defines a neutral conductor that is close to earth potential. It is an advantage for appliance designers to preserve that distinction. For example, appliances may ensure single-pole switches interrupt the line side of the circuit, or ensure that screw-base lamp holder shells are connected to the neutral side of the supply, minimizing the chance of contact with live parts. This requires a plug that can only be connected in one way to the socket, so that the energized and neutral conductors are not interchanged. In most designs, such polarized plugs cannot be mated with non-polarized sockets. Wiring systems where both circuit conductors have a significant potential with respect to earth do not benefit from polarized plugs. Polarization is maintained by the shape, size, or position of plug pins and socket holes and socket recesses to ensure that a plug fits only one way into a socket. The single-pole switch of the appliance is then connected in series with the energized wire. For an appliance such as a toaster, wiring the exposed heating wires on the neutral side of the switch provides a small measure of extra protection against electrical shock. However, due to the uncertainty in practice of which conductor is the neutral, modern toasters sometimes use dual-pole switches which interrupt both conductors. Similarly, lamps with screw bases will connect the shell of the lamp socket to the neutral conductor. Interchange hazards: plugs and sockets are designed as a system to meet standards for safety and reliability. Some types of socket may accept more than one type of plug, where this is an official, approved intention of the socket design. All the approved combinations will be tested to the applicable safety standards. Occasionally, plug and socket combinations may allow power to flow but may not meet product standards for mating force, earthing, current capacity, life expectancy, or safety. Improvised or user-modified connectors will not meet the product safety standards. Adapters between different standards can overcome mechanical incompatibility. Physical compatibility does not ensure that the appliance and socket match in frequency or voltage. Appliance connections and extensions so that manufacturers need not build, distribute and maintain many similar appliances differing only in the type of plug fitted. A common strategy is to provide an IEC 60320 inlet on the appliance and a detachable power cord to allow connection of the appliance to the socket. The appliance need only to be tested to the power inlet. Some types of appliance require the consumer to also change a switch to adapt to different voltages or frequency. In addition to sockets permanently attached to building wiring, extension cords are used for temporary connections when a socket is not within convenient reach of an appliance's power lead. Portable equipment such as gardening power tools may have a male power inlet compatible with the connector at the end of an extension cord. This allows one long cord to be shared among several tools. and so save storage space and cost for the consumer. Multiple small appliances may be connected to sockets on a power strip, which can also include switching, surge voltage and overcurrent protection. A power strip equipped with different series of plug-and sockets can act as an adapter for imported equipment. Special-purpose plugs and sockets. Special-purpose sockets may be found in residential, industrial, commercial or institutional buildings. Examples of systems using special-purpose sockets include clean earth for use with computer systems, electric car charging, IEC 62196 SAEJ 1772, Type 2 connector, emergency power supply, uninterruptible power supply for critical or life support equipment, isolated power for medical instruments, tools used in wet conditions, or electric razors. Balanced, or technical, power used in audio and video production studios. Theatrical lighting. Sockets for electric clothes dryers, electric ovens, and air conditioners with higher current rating. Special-purpose sockets may be only labeled or colored to identify a reserved use of a system, or may have keys or specially shaped pins to prevent use of unintended equipment.